The core science. Why machines heat up. Every functional machine, from a mechanical car engine to a silicon microchip inside a server, faces a fundamental physical limitation, the generation of waste heat. When energy changes forms, it is never 100% efficient. In mechanical systems like an internal combustion engine, heat is a byproduct of friction and literal fuel explosions. In digital systems like a personal computer, a smartphone, or an enterprise server, heat is generated by electrical resistance. As millions of microscopic electrons rush through tightly packed silicon pathways to process data, they collide with atoms, transferring kinetic energy into thermal energy. If this energy is not continually drawn away, the temperature will rise until the materials structurally fail, causing silicon to fracture or metallic components to warp and seize. To combat this, all cooling systems exploit the universal laws of thermodynamics, which state that heat will naturally move from a zone of higher temperature to a zone of lower temperature. Engineers utilize three primary mechanisms to facilitate this movement. Conduction, the direct transfer of heat through solid contact, such as a hot processor touching a copper block. Convection, the removal of heat using a moving fluid medium, such as air or liquid flowing over a hot surface. Radiation, dissipation, the final shedding of that heat energy into the surrounding atmosphere, typically enhanced by expanding the surface area via ultra-thin metallic fins, heat sinks or radiators. Automotive cooling systems, mechanical heat management. An internal combustion engine operates like a controlled furnace, with internal combustion temperatures frequently exceeding 2,000 degrees, 3,600 degrees. To manage this, automotive platforms use a high-capacity liquid loop system designed to maintain a stable operating window, usually between 90 degrees and 105 degrees. The process relies on a continuous loop of engine coolant, a 50-50 mixture of water and ethylene glycol. Water provides high thermal capacity, while glycol prevents the mixture from freezing in winter and raises its boiling point to prevent vapor locks. A mechanical or electrical water pump forces this coolant through an internal labyrinth of channels cast directly into the engine block, known as the water jacket. As the liquid passes through, it acts like a thermal sponge, conducting heat away from the cylinders. The fluid then travels to a mechanical gatekeeper called the thermostat. If the engine is cold, such as right after startup, the thermostat remains closed, forcing the fluid to bypass the radiator and loop back into the engine block so it can reach efficient operating temperatures quickly. Once the coolant hits a designated threshold, typically around 82 degrees, an internal wax capsule expands, forcing the valve open. Cooling is important for you, your life in indirect and direct needs. Like and subscribe.